All right, we're going to take our solving of inequalities one step further, and we're going to involve the idea of absolute value. Now, a couple quick reminder that remember whenever you take the absolute value of a number, it is always positive. So the absolute value of 5 is 5. The absolute value of -5 is also 5, because remember, absolute value represents distance. So understanding that the two numbers inside of our absolute value can be positive or negative, both yielding a positive 5 on the outside, what are two numbers that we can use to take the absolute value of that will equal 3? Well, hopefully 3 and -3 are the two numbers that come into mind. So there are two solutions possibly when you're doing absolute value. Okay, and the two solutions are -3 and 3. The absolute value of -3 is 3, and the absolute value of 3 is 3. All right, what about absolute value equal to -3? Well, we just got done. Whenever you take the absolute value, you get a positive. Whenever you take the absolute value, you get a positive. So therefore, absolute value cannot equal a negative, so therefore there are no solutions, okay, to this situation, and x can't equal anything. All right, but then sometimes you get the absolute value is equal to 0, and since 0 is neither positive nor negative, there is only one solution, and that is 0. So 0 is the only number. 0 is 0 away from 0 on the number line. All right, so that's just a quick little review. So now what we're going to do is apply that to our inequalities. And so if we look at example 1, we need to be able to take the absolute value of a number and have that value be less than 3. So the first number that comes to my mind is 2. The absolute value of 2 is 2, and 2 is less than 3. Okay, 1. The absolute value of 1 is 1, and that's less than 3. 0. The absolute value of 0 is 0, and that's less than 3. I could use -1. The absolute value of -1 is 1, and that's less than 3. I could do -2, and the absolute value of -2 is less than 3. Now, you would think -3, but remember that the absolute value of -3 is 3, and 3 is not less than 3, so I can't do -3. So what that means is that all the numbers from -3, but not including -3, so I'm going to use an open, all the way to 3 are solutions. I can't use 3 because the absolute value of 3 is 3, and that's not less than 3. So everything in between. So remember, whenever we're talking about in between, this is going to be an and situation, which means I can write this as x is less than 3 and greater than -3. All right, example 2 over here. To start, I want numbers that are greater than 3. So naturally, I think of 4. The absolute value is greater than 3. 5, 6, so on and so forth. So what about some negative numbers? Well, what about -4? The absolute value of -4 is 4, and that's greater than 3. -5. The absolute value of -5 is 5, and that's greater than 3. Same with -6. So now we have the situation where we want numbers that are greater than 3. Remember, we can't use 3 because it wouldn't be greater than 3. And then we want numbers that are less than -3, like -4, -5, and -6. So now we're going to go this way. So that means that x can be less than -3, or, notice it's an or because the arrows are going away from each other, x is greater than 3. All right, example 3. Well, now I want situations in which the absolute value is less than -3. Well, we just got done saying over and over and over again that whenever you take the absolute value, you always get a positive number. Well, what positive numbers are less than -3? None. So therefore, no solution. Your absolute value can never be less than a negative number. Okay, in case number 4, I want the absolute value of a number that would be greater than negative 3. Well, since the absolute value always yields positive numbers, the absolute value of every number that you could possibly think of will be greater than negative 3. So therefore, any number in the world works. So we want all real numbers in this situation. And remember, when we do all real numbers, we graph the entire number line. All right, so a little helpful thing for you down here. And you see an example of it up here with case number 1. Anytime you have the absolute value and it's less than a positive number, it is going to be an AND situation, okay? Which means, remember, we're going to put X in the middle, and then we're going to use like less than or equal to signs. And then we'll have two numbers here and there. Anytime that it is absolute value is greater than a positive number, then it'll be an OR. So X is, less than or equal to, let's just say greater than some number, or X is less than some number, okay? So just something to help you, less than and greater. That'll help you. All right, let's flip over to the back side. All right, so now I'm going to teach you how to solve when you have an absolute value equation, okay, with our inequality, okay? So it's very simple, all right? The very first thing you do is you write what is inside X. You keep the inequality the same, less than or equal to, less than or equal to 8. And then you write another inequality. You keep the inside, X, but this time you flip the inequality, so we go greater than or equal to, and then you change the number to a negative, so negative 8. So we have X is less than or equal to 8, X is greater than or equal to negative 8. Now, thinking ahead based upon one of the things we just talked about is that since it's a less than, okay, that means that since we started with a less than, this is going to be an and situation. If you need help figuring that out, think about graphing it first. So if I start with negative 8 and I want greater than negative 8, greater than or equal to, I am going to go this way. Then when I go to graph less than or equal to 8, 8 is over here. I'm going to use a solid for less than or equal to. Less than or equal to would be this way. Okay? So therefore, I am graphing everything in between. That is when we have and. So that means X is less than 8, less than or equal to 8, and greater than or equal to negative 8. So this is the way we would write our and then this is our graph. All right, in example B, I start with X is greater than 2/3, and then I do X, I switch the inequality and go less than, and then I change the 2/3 to a negative 2/3. Okay, now remember that we said if it's a greater than, think about greater. So this is going to be an or, as in X is greater than 2/3, and X is less than negative 2/3. So on a number line, if I had negative 2/3 here, and remember I'm not going to fill it in because it's less than, I would go this way. And if I had 2/3 over here, again, I'm not going to fill it in, and I would go this way. That's an or. All right, example C. So using the same concept that we've been talking about, I take the part that's on the inside, X minus 5. I keep the inequality and the number the same and go greater than or equal to 7. Then I take the part on the inside, X minus 7, or X minus 5, sorry. I flip the inequality and go less than or equal to, and I change the 7 to a negative. Now I just solve them. add 5, add 5, and I get x is greater than or equal to 12. Add 5, and x is less than or equal to -2. So remember, this is a greater, so that means it's going to be an or. X is greater than or equal to 12. X is less than or equal to -2. So -2 would be here. 12 would be here. Greater than or equal to would look like this. Less than or equal to would look like that. All right, I'm just going to keep going. If I'm going too fast, just pause the video. All right, if you recall back when we did our absolute values, one of the very first things that we said was you need the absolute value by itself first. So I am going to start by subtracting 3, and now I've got the absolute value of -4x is less than 8. So now when I go to write my two inequalities, I take the part that's on the inside, -4x, I leave the inequality the same and go less than 8. Then I can take the part on the inside, -4x. I flip the inequality and change it to a -8, so greater than -8. Now I'm just going to solve. Divide by -4, divide by -4. Since I'm dividing by a negative, I flip the inequality and make it x is greater than -2. Divide by -4, divide by -4. Since I'm dividing by a negative, x is less than 2. So I have x is greater than -2 and x is less than 2. If I need to think about what that situation is when I graph it, so I start with my smaller number on the left, -2, greater, 2 is here, less than, so it looks like I am graphing in between. So x is between 2 and -2. So it's an and situation. All right, cruising along. E, I'm going to keep going with this idea of isolating the absolute value first. So I am going to add 8, and from here I got 3 times the absolute value of 5m minus 6 is less than or equal to 21. I do not distribute across absolute values, so I divide by 3 and divide by 3. And now I've got the absolute value of 5m minus 6 is less than or equal to 7. Now I can create my two inequalities. The first one being 5m minus 6 is less than or equal to 7. The second one being 5m minus 6 is greater than or equal to -7. Flip the inequality and change the sign. From there, I am going to add 6 over and get 5m is equal to 13. All right, sorry, is less than or equal to 13. Divide by 5, and now I've got m is less than or equal to 13/5. Over here, I'm going to add 6 and get 5m is greater than or equal to -1. Divide by 5, and m is greater than or equal to -1/5. Okay, so now I have -1/5 here on a number line. I have 13/5 here on a number line. Since I want greater than or equal to -1/5, I'm going to go this direction. Less than or equal to 13/5, I'm going to go this direction. Since it's an and, it's everything in between. And remember, I can write that then as x is less than 13/5 and less than or equal to 13/5, greater than or equal to -1/5. All right, I'm just going to keep going. I am on F, going to add 2 over. I've got 2/7 times the absolute value of 4f plus 6 is greater than or equal to 12. Remember that in order to get rid of this fraction, I am going to multiply by the reciprocal, 7/2. 7/2. this cancels. That leaves me with the absolute value of 4f plus 6 is greater than or equal to, and 12 times 7 is 84, divided by 2 is 42. Now that I have my absolute value isolated, I can create my two inequalities. I can go 4f plus 6 is greater than or equal to 42, and then 4f plus 6 is less than or equal to negative 42. Remember, always just change the sign and the inequality. I'm going to subtract 6, and get 4f is greater than or equal to 36. Divide by 4, and f is greater than or equal to 9. I'm going to subtract 6, get 4f is less than or equal to negative 48. Divide by 4, and get f is less than or equal to negative 12. So on my number line, I got negative 12 here, I got 9 here. I want less than or equal to a negative 12 going this way. I want greater than or equal to 9 going this way. When they're going away from each other, it's an or. And so x is greater than or equal to 9. X is less than or equal to negative 12. All right. If I go down to G, okay, on this one, I am going to subtract 8. 3 times the absolute value of m minus 1 is less than or equal to negative 3. I'm going to divide by 3 and divide by 3, and I get the absolute value of m minus 1 is less than or equal to negative 1. Now, absolute value is always positive, and a positive will never be less than a negative, so therefore, no solution. And don't even graph. H, I am going to subtract 8. I have 3 times the absolute value of m minus 1 is greater than negative 3. I'm going to divide by 3. The absolute value of m minus 1 is greater than negative 1. All absolute values are positive, which are greater than all negative 1 all the time. So therefore, it's all real numbers, and I would shade the entire line. So notice that I didn't even bother creating two inequalities, because you can kind of, if you think about the problem, especially when you get a negative, it's either all real or it's no solution. All right, come with questions tomorrow in class.